Welcome back to Ye Old Foundry, ladies and gentlemen. Today's subject is going to be how to make a bell, how to ram up and cast a bell. There's many ways to do it, but in the Navy we usually only did it just a couple of ways. You know, it depended on what kind of bell it was, well, how big it was, and so forth and so on. But today, you know, let's see, I can think of maybe 5 ways of making a bell, but 2 of them are the ones I'm going to cover now. Here's your basic bell. Now this I got over at the a thrift store, and it's one of those that I think it's from India or Pakistan. Made in India. Yep. And it sounds real nice. This is made out of brass, obviously. If you can see, it's a high, you know, much more yellow than it is red. If it was more reddish tinted, it'd be a bronze. And that's how you can tell it, more or less. Okay, here is a copy that I made on my 3D printer. I'm going to make one of these also. So the thing is, though, when you're ramming them up, you can see the top, you've got a bunch of holes in there. That won't be reproduced when you ram it up. Okay, because unless you had a core specifically made to, you know, to copy this portion, the hanging portion, okay, you're just going to have to fill that in and then drill out those holes, the holes that you have in there right there. You can drill them out later and make it look nice. Anyway, you've got several different types over the centuries of metal that bells have been made of. All right, made them out of copper. Didn't sound too good, but that was the material they had at the time, so they lived with it. They finally learned how to make bronze. Those made the bells look much nicer, or rather sounded much nicer then. Matter of fact, our ancestors really seriously thought that the sound, pardon me for a second, the sound coming out of a bell was the songs of you know, of like angels or spirits trying to talk to us. There was nothing else in their life that sounded like that. It was beautiful. It was made every, you know, calmed people down when they heard it. Okay, used it in a lot of religious ceremonies. To you know, the Chinese used them to scare away evil spirits because it was a sacred sound, and they thought the evil spirits couldn't stand it. Our ancestors in Europe and in, well, Great Britain used to use it as part of their religious ceremonies to mark the time. You know, it was like them saying, "Everybody come on in, we're going to have a ceremony." Okay, that reminded everybody that was all busy that when they heard the bell, it was time to go to the church. Okay, so there was many ways, or many reasons for having a bell in the old days. Nowadays, they're basically nothing more than ceremonial. You know, not ceremonial, but good looking, and they sound good at your homes. On the ships, we use those as a signaling device, like when the captain was coming on board. There were signals for every rank, okay, but the captain, you know, he was an actual captain. For coming on board the ship, it would be, and then we would announce who he is. In my last ship, on the USS Yosemite, the captain was totally equated to the ship itself, and we would announce Yosemite arriving. And that's what we used them on the ship. We also used the really big bells that were set way forward on the ship. Now these things probably were 800 pounds. They were quite large. Of course, brass and bronze is a heavy material anyway. But they had it all the way forward near what's called the forecastle, the pointy end of the ship. And whenever we were running into really bad fog, which I think we ran into fog one time in my 20 years in the Navy, where we had to actually use the bell. When we went through heavy fog, you know, you couldn't trust anything. You didn't know if radar was going to be good enough to find somebody. So we went back to the old methods, and we would have the ship's bell all the way forward, the ship's bell, and the steam whistle that was way up as high as it could be on the mast. Okay, and the reason why that is because they know that in fog is basically in layers. It's not the same consistency from the outside edge of the fog's edge all the way to the center. They said that it's like in layers. So you would have a layer of fog, a layer of less fog, you know, and so knowing that, they knew that the thick layer of fog wouldn't be very helpful in trying to allow noise go through. So the bell that's nearest the ocean, that would be rung a certain signal. I don't think I ever studied that, what bells they were, but there was signals on that bell to try and get everybody that is away from us attention to say, hey, here's a big ship, don't run into me. Okay, and they did the same thing for the big steam whistle up top, way up, so that if you didn't hear the bell, we would hope that you would hear the big steam whistle. And that would be, you know, it's almost like the well, you may have seen, it's like, you know, you pull on the handle and steam goes through it, and it's a very loud, you know, deafening sound. Okay, so that's what we used bells in the Navy for. And so periodically in the foundry, we would be given a job order to make a bell. Maybe one of the small ships that come alongside lost their bell. Maybe somebody stole the bell when it was supposed to be in secure storage. And these are basically the bells on the quarterdeck. The bells on the quarterdeck, well, kind of, let's say that the bells on the quarterdeck was like 5 or 6 times bigger than this. The opening here was about that big. And the height of it, about that tall. And those were used for, as I said before, well, they would signal what time it is, and they would signal when somebody important is coming on board or leaving the ship. And they would also be signals. You would be using it to announce that there's a fire on board, okay, or any other emergency. All right, when you heard that bell going, you knew it wasn't a joke. And so if you were part of the damage control team or the firefighting team or any of the other emergency teams, you jump up and you get going to where you're supposed to report to. Now that that's explained, ages ago, when they really couldn't make a lot of brass and bronze because it was very hard to find find the copper, and it was hard to find the chemicals to make tin and combine them and make them into a nice bronze bell. They would go and use iron in many cases. Any of you who lived on a farm, especially in New England, you might have seen one of those iron bells. That's and they used to use those to signal the cattle, hey, it's time to come in, okay? Or if it was time for lunch, the lady of the house or one of the kids would ring it, and then somebody out in the field, the owner of the farm or ranch, would hear it and they'd say, hey, it's time to go eat, and then they would come in. It was a signaling device, in other words. But there's a couple of elements in this. You can have bronze. You can make one out of bronze. You can make one out of bell. I mean, make a bell out of bronze. You can make a bell out of brass. You can make a bell out of iron, which they have many times. And nowadays, now that aluminum doesn't cost an arm and a leg to make, you can make out of aluminum. There's lots of elements or alloys that you can make it out of, but not all of them sound worth a darn. Okay, you try to make one out of zinc, all you'll hear is thunk. You know, it won't be a ringing. Okay, so the first thing I'm going to talk about is making bells out of a material that's less likely to produce dross when it's, you know, when it's going through some turbulence. Okay, and the two elements, or rather the two alloys I'm going to talk about now, is aluminum. Thankfully, that's what I'm going to be pouring, because I can do that yet, and I haven't improved my furnace enough to pour brass and bronze yet. Or you can pour it out of iron. Okay, the same technique is used to pour those two materials that really don't produce a lot of dross when they have to go through an area of turbulence. The thing about aluminum is that if it goes through a lot of turbulence, it might trap some air bubbles, because the air bubbles are going to be covered over by this hot material and get trapped, because it's almost immediately that the outside and inside skin of the mold cavity solidifies, and so the air is going to be trapped in between, and that will affect your the tone of the bell. Okay, now brass and bronze, now that's an alloy, that's a copper alloy, and they are horrendous for manufacturing dross. Okay, now if you haven't at this stage seen the videos that I made that discusses dross, I'll give you a real quick overview. When you have, let's say, I really don't have nothing for a good example. Okay, let's say this is the pattern that you're going to use, and you've got it rammed up in such a way as you're just going to pour it straight down here. Well, you're going to maybe have a sprue that's about that long. It's going to come down, it's going to hit my goodness, there's nothing in here, I don't think. It's going to hit the top of this green sand core and tumble down this and hit down here at the bottom and splash backwards, and you're going to have dross being manufactured. Now let me double check and make sure that this is pointed correctly. Okay, that's a little better, I think. Now I've got this set up to where when I'm talking about the one metal, I'm done with it. I can turn it over and talk about the other metal. This is the way I would ram it up if I was using non-dross producing metals, like, well, I say non. There's always a chance of some of it's going to produce some kind of dross, but it's less likely. Iron and aluminum in this case, you would have this. By the way, is a half view. This is the drag. This is the cope. Okay, here's the alignment pins, and this is where this is not the sprue hasn't been cut yet. So over here represents the sprue being cut. It would go right into this portion here that holds. That's the thicker, actually one of the thicker parts of it, because it'll hold the bell in place wherever you're putting it. It hits the top of this, it rolls down and fills up and goes back up, and you've got a solid bell. Okay, and the odds are very good you're not going to have a whole lot of dross or you got to watch out for it, but you can always do it over again anyway. Okay, so I would just cut an opening right here on top and pour straight down in there, and you can make the assumption that you're not very likely to have any dross in your bell at the time. Now, opposite way, let's see, Yeah. The opposite is brass and bronze. Pardon my back. Okay, I turn this over to show you. Now this is the way we usually had it in the Navy. Okay, we would have the green sand core hanging, so we would always have to have some supports in here, like gaggers and soldiers and other supports that would hold this green sand core from falling, because all you got is just this one little area holding. All this other stuff up here doesn't mean a thing, because right here is where it would crack off and fall in there, and it would ruin the whole mold. Okay, so you put in a bunch of mold supports that go, you know, some of them. I wish I brought the drawing, the dry the whiteboard, not crayon, but drawing, you know, pencil. Anyway, you would have to have like an L-shaped gagger go all the way up to the top and have it do another L shape, so that the edge of your flask, you can't see over there, the edge of your flask would be sitting on the edge of your flask, and so the flask itself would be holding the gagger in place, and it would be holding that. Now we had very infrequently did we ever have any green sand cores fall out. It happened, but it just taught us more about how to you know, make the mold supports and why they're actually needed. Okay, now the way it would this is basically the way it was set up, and these pins would be opposite. Okay, now the way we feed these is that if we're looking down at the or let's pretend we just took the cope off out of the way, and now we have to cut the splash basin and runner and ingates. This is what it would look like. Here's your green sand core. This is the mold cavity that the metal would be pouring into, and ingates, runners, splash basin. Come in, fill up, flow all the way to the end. Any dross at that point is being pushed to the end over here. That's what this extra metal is for. I mean, extra runner is for, is that if there's any sand or dross then captured in this flow, it'll be pushed all the way to the end and not go into your mold cavity. Okay, once these fill up, pressurize, then the ingates would be filled up, and then the metal would be flowing down to the bottom, and it would fill back up. Now as it flows in, it's going to have a little bit of turbulence too, okay? But the deal about this method is that, you know, that dross is basically just like hydrogen mixed in with the metal, and that makes the dross. It turns into an element all of its own. Not element, but a alloy all of its own. And it is, at that time, now lighter than the original material. It's lighter than brass or bronze. So if it's made, it's got a lot of dross. See these little arrows right here? That represents the dross being displaced by the heavier metal, or the more pure, heavier metal, and being pressed and pushed against the green sand core. Okay, go up against the green sand core, and the dross that you'd be making would be captured against the inside of the bell and not be seen on the outside of the bell. Doesn't hurt anything if there's a little bit of dross on the inside of the bell, because the inside of the bell can be machined out just a little bit, and it would improve the sound. Okay, so you got two ways that you can do it. The ways we did it is depended on the material, and our material was almost always copper. based material, copper alloy, brass or bronze, depending on what the people who ordered the bell, what they wanted. Okay, and for those of you who want to make actual bells that had the traditional bell metal, the alloy called bell metal, here it is. Bell metal, 78% copper, 22% tin. It has been found over the centuries that that combination makes the cleanest, most beautiful sounding bell sound that they've ever found. I mean, it was over the centuries that the molders and the foundrymen, or rather the furnace operators, would experiment and try to find out which combinations of elements would make it the best. Okay, and they found out that this was the best, and that's what they settled on. And as far as I've ever read, they've never changed that. Okay, so this is a bronze alloy. Okay, if you have one, if you're making a bell out of brass, which is a copper and zinc alloy, you're doing it not so much because of the sound, but because of you can make it a bright golden color if you machine it and then buff it out. It's much more attractive. Okay, but it doesn't have that same beautiful tone as this. Okay, and let's see, that's basically the explanation of that. Now, as I said, there is at least 5 different kinds of bells that you can, different ways you can make bells. You got those 2 ways. You've got, let me turn this back over. You've got a way of making it with what's called a sweep, and basically that's basically the shape of the sweep right here. What you're trying to do when you use a sweep is you're trying to copy on this. Let's say this is made out of sheet metal. It's got to be stiff enough to where it can work its way through the sand or whatever molding medium you're going to be using. And this here, right here, there would be a long rod going to, well, there would be the bottom board here, going to the bottom board, and you would make a big pile of sand here. The sweep would be put on top of the rod and shoved down into that pile. You would put a nut on top of the rod to hold this in place, and then, now this wouldn't be part of it. And then using the sweep, you go slowly round and round until the sand that's not supposed to be there would be chopped away. It would be carved away. And you go through for the drag, you'll be carving away, and you'll be forming the green sand core, or the core for the inside of the bell. Now you go and you ram up this part of the mold, and you use the sweep to form the outside edge. This is what this edge represents. Okay. Now there's another way of making it. You can make them out of. You can make one out of wax. Make it very decorative, and then use the lost wax method to form the outside of the bell. Okay, you couldn't use that for the inside of the bell because this portion of the bell, the core, has got to be able to be collapsible. Okay, when this solidifies, it's going to come in like that, right? It's not going to expand, it's going to contract. And it'll contract evenly over the green sand core, and this green sand core has got to be able to be crushable. Otherwise, you're going to have what our most famous bell, the Liberty Bell. You're going to have a crack in it. Okay, and I think looking at it from a molder's perspective, whatever they used to make the inside of the bell, they didn't make it collapsible enough. So that history says that the first time they used the bell, they tried to bang the, use the clapper on the inside of the bell to make the tone. It immediately popped, and there was a crack right in there. That tells me that, yeah, the metal solidified, the very first skin of it solidified, but they had a lot of stress in there, and the first time they hit it with any vibration, the stress showed up at that crack point and just opened up. Okay, you want to keep your bells from doing that. Make a core in here, like the green sand core. Okay, that will crush as this solidifies. Now here's another way you can do it, but this would be way too much work. If you've got molding sand, you do it this way, okay? But another way, if there's a reason why you have to do it there, this is another technique. You can take and ram it up like this, right? You're going to have to make a core out of whether it be good gravy. The stuff with the you can make the kind of cores that you can bake, okay, and don't make any that are so strong that it won't collapse. Okay, CO2 cores, CO2 cores, they're very, very strong. Okay, it's more like using the outside. They'll be nice and strong for that, but they're so strong that they won't crush, and then this will split as it solidifies. Okay, so you can make a core print out here, whether it be if you're a good woodworker and you've got a wood lathe, you can make the inside here out of the wood, and then make a core print out here, make a core box for this, and then you make the core and you bake it so it stays nice and solid, but it's not so solid it can't be crushed. And then you can put, it's just so much work. You could in-gate here or in here. You could put an in-gate here, you could put an in-gate here, and it'd be just so much work. My phone just went off. We've got the that ring device that you could put on your front door, and if anybody comes up to my door and I don't know them or all that, we can tell them, go, shove off, get out of here. But the alarm that I have on it is barking dogs, and that gets my attention right away, and it tells me, no other reason would I have anything barking, so it tells me that somebody has set off the sensor at the front door. Anyway, back to this. Okay, now I have changed my flask a little bit. It looks a lot more like what we had in the foundry on board the ships. Now, if you remember what I had before, is I had a couple of pieces of wood here that I angled in slightly to make a wedge shape, and then I put another piece here so that when I set this down, the one piece up here would go in between those two that are down here, and it would line up and it would close. Okay, that was fine, except the stupid things were not made real well. Okay, I made them, I know. But thankfully, I was watching Toho Mott's website. Oh my gosh. One moment. Easier just to turn it off. So this one fella, you know, I like to watch a lot of the guys who do their own foundry work. I like to watch them, and ever so often they show me a better way of doing things. Tobho, now it's not very easy to pronounce. Tobho Mott, okay, showed me a way of making alignment pins that I hadn't thought of before. All right, basically what you do is you get yourself, this is a 5/8 inch bolt, okay, and the neck of it was this long, and there's my threads. On top here you had a hex shaped, you know, not a nut, but the head of the bolt, right? Well, it turns out it was an easy thing to do, but I just never thought of it, that all you got to do is chop off the head of the bolts, and grind it down to where it helps you align it, and you got your pins, just like when I was in the Navy. You got your alignment pins, so that this can come up easy with very little movement. And of course you still got to be watching out not to do this part. You're just going to have to learn how to do. And the it's going to be so much easier to ram up and make sure that nothing gets broken as you pick up. Okay. Anyway, there's that. So okay. Anyway, and a couple of more things. I mean, I've done some things around here that I've got to show, because in the near future I'll be ramming these up. I took my molder. Goodness sakes. I'm sorry. Didn't mean to knock you over. Took my molder plaque and glued it to the top here and made my runners, okay? And you know, someday I might be able to do brass and bronze, so I made sure that I had the extension here, okay? It's still, making an extension at the end of your runner is something that I highly advise you to get into the habit of doing, because even if you're not working with brass and bronze, the sand that you might not have seen, like in the down sprue, it might get pushed down into here, the splash basin, and then it'll get pushed all the way to the end and not go inside your mold cavity, okay? So that's this. I made the fillets out of caulking, which is just as easy to form with your fingers, and they turn. I mean, I'm not going to make 1,000,000 of these. I'm only going to make probably half a dozen at most in my lifetime, okay? So I'm not going to be worried about this stuff getting too tore up. I'm just going to let it dry out. And here's another one, and I'm going to let it dry out and let it cure, and it'll be tough enough that I can ram it up. And there's the one that I made for my wrapping tool. There's a couple of guys out there I see using a you know, like a bolt like this to try and loosen their molds, or rather their patterns in the mold cavity. And I said, oh man, it just kills me to watch them do that. You get much more control over something with something like this than you do a rod or a dowel, okay? So this is also curing right now, and in the near future I'll be making some of these. Anyway, so I guess that's the basic subject of making a bell. Okay, I will be ramming up. I'm going to try this one and this one. There's plenty of room in here to put two of them side by side. So the odds are good that I'm going to be doing that. What I'm doing, what my intention is with these different shapes and sizes of the bells, is that I'm going to make wind chimes. Okay, they sound real good. I've had some aluminum bell, and it sounded good to me. And if they come together, it'll be a part of my problem, is to try and arrange these where the wind will come together and do that. Okay, so now it's a matter of me putting my furnace together and see if the technique that old foundry man uses for his, his furnace works in mine. Heck, if it works for him, it should work for me. I got to test that though before I can show you me pouring the molds when I get them done. Okay. So this is going to be kind of a short video. I just wanted to let everybody know I haven't passed on yet, although I am 66 now. You can't plan that far ahead. So I'll be making these molds and pouring them after I test my arrangement in the furnace, and we cross our fingers everything will go good. Okay, so please, everybody who's previously in the Navy, I was reminded that I had forgotten to give a Liberty call. Okay, clean up your shops, take out your trash, and then you can go and get dressed for Liberty. Okay, and I told them I was going to say it twice, so Liberty call again. Please pass the word to everybody you know that's trying to make castings about this site. It's free. It's free. Nobody's making you send any money my way. I don't care about that. I'm interested in getting you guys to learn how to make things safely and make nice solid castings. Okay, so please make a comment, whether it be good or bad. I don't care, and you ain't gonna hurt my feelings. Okay, 20 years Navy, your feelings kind of get dulled a little bit after all the stuff that happens in the Navy. So you ain't gonna hurt my feelings if you say something that's not highly praiseworthy or something like that. So please leave a message, good or bad, and subscribe. You will have 50 or thereabouts, maybe 53 videos to be able to go through, and might be able to make some real good castings for you. Okay, so this is Sand Rammer, aka Tom Kitchen, in Ye Old Foundry, saying goodbye and having everybody wishing a good casting experience. See you later. Bye-bye.